Okay, let's dive right into this. Imagine you're on a road trip. If you press down on the gas and drive twice as fast, do you arrive twice as early? I mean, it's a real-world scenario we've all experienced, right? But underneath that simple question is this incredibly fascinating mathematical engine. Welcome, everyone. If you're focused on truly mastering how different quantities interact with each other in the real world, well, you are in the exact right place.
In today's explainer, we're embarking on a comprehensive guide to DPE 803, Part 2 Mathematics, specifically Topic 226, Variations and Proportions. Look, for a lot of students prepping for their FSC or competitive exams, this specific topic can totally be a source of math anxiety, but not today. We're going to completely alleviate that anxiety by building a rock-solid foundation using clear, structured visual slides to transform these kind of abstract concepts into really simple logical tools.
So here's our roadmap for today. We'll be covering foundations of ratios and proportions, direct variation, inverse variation, third, fourth, and mean proportions, continued proportion, and finally, some crucial exam tips and solutions. Let's get started.
Section 1. Foundations, Ratios, and Proportions.
So, a ratio is simply a relation between two quantities of the exact same kind, measured in the same unit. When you write it out as A colon B, that first term, A, is called the antecedent, and the second term, B, is the consequent. But here is the absolutely crucial takeaway, and honestly, this is a classic trick question on exams. A ratio has no units. Seriously, none, because you're dividing two identical units, like meters by meters. They just cancel out completely. It's just a pure relationship.
Now, you might be wondering, what happens when you set two of these pure relationships equal to each other? Well, you get a proportion. It's basically a statement expressed as an equivalence of two ratios. So if A is to B equals C is to D, that's a proportion. The official textbook gives us two vital exam terms to remember here. The outer quantities, A and D, are called the extremes, while the inner quantities, B and C, are called the means.
Let's move to and see how this builds into solving an actual textbook problem. Suppose 7 kilograms of sugar costs 560 rupees, and we want to find out the cost of 15 kilograms. We just set up our proportion. 15 kilograms is to 7 kilograms, as X rupees is to 560 rupees. The golden rule here, the product of the extremes always equals the product of the means. So we multiply our outer numbers, 15 and 560, and set that equal to our inner numbers, 7 times X. Solve for X, and boom, we find that the 15 kilograms cost 1,200 rupees. See? Simple, structured, and completely logical.
Moving right along to Section 2. Understanding direct variation.
Now, what's really interesting about this slide is how we write out direct variation. When quantity y varies directly as x, we use this little proportionality sign. But to actually do the math, we have to replace that sign with an equal sign and a constant, which we call k. So we get y equals k times x. Think of driving a car again. The faster your speed, the longer the distance you cover. They move together, right? Linked by that constant rate.
Next up, Section 3. Understanding inverse variation.
Okay, so with inverse variation, it's a bit different. Here, y is directly proportional to 1 over x. This means that to find our constant k, we don't divide, we actually multiply. X times y equals k. Going back to our driving example from the very beginning, the faster you drive, the less time it takes to reach your destination. Speed goes up, time goes down. One increases while the other decreases, but their product, that remains perfectly constant.
And this brilliantly illustrates the difference between the two. For direct variation, both variables move in the exact same direction, and their quotient, y divided by x, is a constant. For inverse variation, they move in opposite directions, and their product, x multiplied by y, is the constant. You're going to want to lock this table into your memory, for sure, because knowing whether to divide or multiply to find k is literally half the battle on any math exam.
All right, Section 4. Third, fourth, and mean proportions.
Let's start with the fourth proportional, which honestly is the easiest. If four quantities are related as A is to B, as C is to D, then that last variable D is simply called the fourth proportional. That's it. You solve it exactly the same way we solved that sugar problem earlier. Extremes equals means.
However, if we only have three quantities to work with, we relate them as A is to B, as B is to C. Notice how the middle term B repeats. This repeating middle term acts as a sort of structural bridge between A and C, and it is officially called the mean proportional.
Because our rule of extremes equaling means still applies, b times b, which is b squared, equals a times c.
This brings us to section 5, continued proportion.
So, when three quantities, A, B, and C are related in that exact bridge format we just talked about, A is to B as B is to C, they are said to be in continued proportion. It really ties everything together. The first term A is the first proportional, B is the mean proportional, and C is the third proportional. So, if a test question ever asks you for the third proportional, just remember, it's simply the C at the very end of a continued proportion chain.
Finally, Section 6, Exam Tips and Solutions.
So, the crucial point is that beyond the basic calculations, you absolutely must know some of the theoretical properties. Take invertendo, for example, which simply means if A is to B equals C is to D, you can just flip them upside down, and B is to A equals D is to C is also perfectly true. Or alternando, which allows you to swap the means, so A is to C equals B is to D. Honestly, knowing these shortcuts can save you some serious, precious minutes on a timed test.
Before we wrap up, here's your rapid-fire revision checklist. Go ahead and screenshot this slide if you need to. Let's review. Ratios have absolutely no units. For proportions, the product of the extremes equals the product of the means. So A times D equals B times C. Direct variation, that's Y equals K times X. Inverse variation, X times Y equals K. And for the mean proportional, B squared equals A times C. If you commit these 5 core concepts to memory, you're going to totally dominate Topic 226.
As we close out this explainer, I want to leave you with a bit of a conceptual challenge. It's a real-world physics application of the inverse variation we literally just learned. According to Newton's law of gravitation, if the force varies inversely as the square of the distance, what happens to that force if you double the distance between two objects? Think about how that word squared affects our inverse math. Keep exploring, keep questioning, and I will see you in the next explainer.